Okay, so I think by now everybody joined. Like always, I will start with what we talked about last week. And if you remember last week, we did some exercises from the last year's exams. And I also asked you to fill in this Wi-Fi crossword that it counts for your activity during the lectures. You can still do this until tonight. So you have some time still if you didn't do until the end of the day. Okay, not really end of the day, I think 5 minutes before or something, but anyway. So you can also do that. And if you don't see your points yet, it's because of that. So basically we finished the Wi-Fi and we started to talk about 5G, which I saw it's not really, it didn't help so much. So there's still not too many students that registered for the course project. There are only 5 by now. So I really strong encourage you to register for the course project for the presentation. There will not be many spots available. We cannot do the course even in the exam session. So if we don't have space, we don't have space. Okay. If you have any questions regarding whatever related to the course by now, before starting. No. Okay, if there are no questions, I will close all this. This were for your colleagues before. I will move forward for what I want us to discuss starting from today. So we move forward to mobile security, and you will see a very big percentage, a high percentage, let's say, of the course is related to wireless security, because whatever we find in wireless, I mean, wireless is more susceptible to a lot of attacks, so it's more difficult to secure. So it's a good thing to look into. So we're going to continue today with mobile security, as I was saying, and except the 5G that we will learn by your projects, hopefully. We will go over second generation and fourth generation mostly. So the 2G, the GSM, and the 4G DLT. So now here in lecture materials, you will find 23 pages on security, and I will open it now. And this is what I want us to discuss in the first place. So we do a short intro in mobile networks. What can you tell me from here? So again, whatever is, please.
There is an to say at each decade or each 10 years there is an increase from 1G, 2G, and so until to say the today where we have the 5G, and in the next decade we have maybe 6G implemented as well.
Yes. So I suppose you refer here. Okay, so we have like this timeline where we have starting from the first generation up to the fifth generation that we are kind of experiencing now. Fully 5G sense, but anyway, and looking forward to 6G and others that I don't really understand exactly what they are, but I need to tell you that there are working groups working on 6G already, even if 5G is not fully here. But yeah, it's like this. And what all this generation bring to us, or why do we go from one generation to the other? And again, if it's quite easy to see at the beginning, first generation, second generation, then we start to have a problem when we start with the, I mean, fifth generation, sixth generation, and so on. Even from 4G to 5G, no, there are people saying, okay, but 4G, at least for us as end users, personal, it gives us whatever. We don't really need 5G, no? How many of you have 5G phones now and use 5G? Is there anyone? Nobody? No, me neither. Then that's because we don't really feel the need, right? It's like 4G already gives you everything you need. You can browse the web, you can have online meetings, you can, I don't know, check videos online. You can basically do whatever you need as a person, no? In 4G. So there's not really this need at the personal level, let's say, to go towards 5G, 6G, and so on. But now, because we're here, and anyway, it's kind of related somehow to the 5G project that you need to do. What is the 5G coming with? Or why do people say, oh, it's good, we need to have it? From what you've heard.
So, sorry, can you repeat the question?
Yes, sure. So I was asking why 5G? Why would 5G be beneficial if we think it? Why we need it? Why did it appear?
So, for example, it's a high density. For example, if say on a stadium where we have 1,000 of supporters, each with a mobile phone connected to the provider antenna, then it's almost impossible to say to provide to them quality broadband, to say. So this is to say one of the reason to say to assure a high density or a high number of clients per in a given, to say, space or region.
This is really well pointed out. And because you talked about that, I want to go a little bit to the architecture. And then we come back to this one. You said,
and another,
yes,
yeah,
please.
another one, it's to say the low latency, for example, the self-driving car, and so where we need to say a latency, I don't know, a couple of nanoseconds to say. It's the 5G assured this low latency and high bandwidth.
Yes, that is true. But then we all the time end up with the question, do we really need it? Do you remember that was this project of Google for self-driving cars? At some point, some years ago.
Yes. Yeah.
And what happened to the project?
No, there are a couple of others, to say, companies in US which are to say obtained a license to use the self-driving cars in certain, to say, states. If I correctly call it one state right now, Arkansas or so, where the Uber or Tesla, and I don't know which one, but they are ready to say obtain a license to have or to use the self-driving car through certain regions.
What I want to emphasize here, and I just take it like an example, but it's a lot of it's a debate problem here. It's like, do we really need so much technology or we don't? And because you brought up these self-driving cars, they were, I gave the Google one just as an example. Of course, they exist, other projects as well. Google stopped it. So at some point they had the self-driving cars project and then they stopped it because there were a lot of problems there. If something happens, who's responsible? So if an accident happens, if somebody's dead, who's responsible? And there are a lot of ethical issues as well. And then you end up asking yourself, do you really, really need it or you don't need it? Or it's sometimes better to have even some people that can interfere and so on. Of course, now it's also at the beginning. So I don't know if you had the opportunity to see a self-driving car. I saw a self-driving bus. And it was some years ago in Sweden. And it was going slower than you were walking almost, because it had to stop and all the time think and calculate a lot. Of course, this can evolve. It's not, but then you really think, okay, do you really need it or you don't need it? And what I want to say here, I don't want to give you any personal opinion or things, but you are technical people. You have a master in a technical domain. Most of you have a bachelor in computer science or something related. Not all the time is good just to say, okay, we're doing it because we need to, I don't know, technology to move forward. Sometimes you need to think, okay, do I really need it? Or whatever I'm doing, think about the trade-off. Do I really have to do that? Can I do it simpler? Is there any way that I can do it in a simple way? What are the risks of doing it? And so on. So don't think, okay, I'm a technical person. I need to think, yeah, I'm pro technology all the time. I might not be. And I give you some other examples from the IoT. IoT, again, everybody knows what it is. Internet of Things. What does Internet of Things mean? It's also security network. So, and we get to network security immediately. So what is Internet of Things assuming?
I think connected to the internet or on a device which.
Yeah. And then what's the trade-off for us in security? Did you hear about the attacks when, oh, I realize if people are home or not, because I realize how much electricity they consume. Because if the people are not home, the electricity consumption is down. If the people are home, the electricity consumption is up because they turn on the light, they open the TV, they turn on the radio, I don't know what. Or, I don't know, even things like it was also some years ago a nice talk at the conference about one person that was explaining why you should not have a Linux-based operation system on your washing machine, because it was possible for the attackers to get into your washing machine by breaking into your system and then taking control about other things in your smart house, okay, or smart cities or whatever, which are also in this Internet of Things or within the 5G. So the risks exposed for us as security people when these things come to life are huge, because it's one thing to be able to secure, let's say, a server or something that is in a proper location somewhere, I don't know, or where you can have a lot of types of defenses. I remember the principles we were talking about at the beginning, no? And it's another thing when you have all the devices that are belonging to end users. They can do whatever with them. They install a lot of software that they don't know what it's doing. And then everything has access in the network, and mostly you base important stuff on that. So the security of your home, the security of I don't know, of your health. You know, maybe there are even these electronic devices for the heart beating, let's say, for the people that are sick, that are really good, and of course we need to have them and so on, but they can be attacked also. Okay. So all the time, for us at least, the security people, we need to think, okay, but there are a lot of things that can go bad, and as many as these new fancy stuff we have, we increase the risks, and it's much more difficult to secure the system or the network, and also because they also appear really, really fast. So we don't really wait to see, to test, to really be sure that something is working. No, this is how it is now. We need to put everything fast on the market and so on. I don't know how many of you saw this one. I will send you a link, the one with the smart house. I will put it here in the chat. And when you have some time that it, let's say, you can have a look. Okay, I will also put it here. Maybe some of you already saw this. So it's one guy that it's having a smart house, and whatever can happen wrong in his smart house. So everything is perfect at some point, and then everything turns out to be really bad. So this is what I'm trying to say even. So I'm not against, but don't be even. So my advice for you is future or even now, no, working in the technical domain is don't be all the time pro technology when it should not be there, even if it's our domain of work. No. Coming back. We started, somebody said, I think Jürgen said something really interesting about 5G and about the number of devices that are connected to the network. And that made me thought about the architecture. So I would like to go a little bit in the general architecture to talk about the general architecture and then see how this architecture evolves from one generation to another. Because he pointed out really well the difference towards 5G. So how can we explain a general architecture in mobile networks?
A list of access points or access antenna of the provider, and those antenna are connected maybe through a fiber link and so, and the devices connected directly to those antennas. And wants to say if it's a mobile user and moving along to say the road or something like that, they change to say the access point of the same to say network provider, and so this is on summary how I understood this architecture.
Okay, this is really good. So in general, if we can really simplify what's happening in the mobile networks, we can say, okay, we have the user devices, the end user devices. So I can have a phone, I can have a tablet, I can have whatever, a laptop, if I'm using to connect via data and so on. And then I have this access network, and it is called access network because it's the point where I access the network. So are all these antennas that you can see everywhere. So up to 4G, you can see them up on the, and even in the 5G, no, on the blocks, for example, or on these pillars, no. Some of them are the ones that are allowing the phone to connect to the access network, so to enter in the operator network. And some are the ones, because there are even the ones going towards the core network that can be linked, or it can be, so it can be cabled or not cabled. It can be wireless as well. But what's important for us? So we have the user devices, so whatever we're using to connect to the network. We have the access network, and then we have the core network. Okay, so basically, if the access network are the antennas, doesn't matter the form, we'll see, that we connect to. The core network is the core, no, as the name is saying. Where is the switching center? Where are the databases of the users, of the subscribers, where everything happens, right? Almost, I mean, all the mobile networks, no matter the generation, can be at a very high level be seen as such. I have some user devices that are connected via an access network, then they get access to the core network, and then of course we can have some other connectivities with some other types of networks. With the fixed network, they go over to the internet, they have connection in between, of course, operators and so on. Okay, so whatever happens here, it's less important for us. What we're going to be really interested about is what happens here in the user devices towards the access network, because this is the one that is more prone for problems or attacks for us. So whatever is in the core, it's the operator business. It's more difficult to get into, to understand what's there. There are more secured. There are physical locations where they're placing their devices, of course, no? While in the access network, they are everywhere. So as I was saying, no, there are the pillars on the street, and there are the ones on the blocks, and so on. Georgi said something really interesting about 5G. What is happening in this architecture in 5G? We have much more antennas to handle much more users, to be even much closer to the users. And now I'm speaking in the really 5G scenario, so not the semi 5G that we have now. And so to give much more broadband, less delay, and so on. So ideally, let's say like this, in 5G, you have antennas everywhere. Did you ever notice, for example, in the subway, the access points that gives you internet in the subway when you're traveling with the subway?
Yes.
Yes. Think that it can be like this in 5G everywhere. So you go to the bus stop and you have an antenna, and then you go to a shop and in front of the shop you have an antenna, and then you go, it might be like this. Okay, or in the example with the stadium that was giving Georgia, you can have much more antennas wherever in the stadium. This again exposes to a lot of new risks, because if I'm a mean person, no, if I'm an adversary, I can just plug it out, or I can break it, or I can change something on it, or I don't know. I have physical access to it. While normally up to 4G, let's say, I was not really, because, okay, I need to go up on the block and put the antenna down, but it takes some. In 4G, there are even some specification, and we will see that how you need to physically protect these antennas. Okay. So 5G brings a lot of problems as well, plus the number of devices that are connected that can be infected and can have problems. Plus the softwareization, because up to 4G we were not putting too much price, let's say, on the softwareization. But starting from 5G, we kind of want to decouple the hardware and the so we want some let's say what was not before. Before we wanted specialized hardware for whatever, because it's faster, because it's easier, no, it's better, and so on. Now in 5G, we say we don't want that anymore. We want some hardware that can move, we can put whatever on top of it. So it's basically, okay, I do everything in software, or as much as I can, I do in software. Just to give an example, the general routing process. No, you have a router. The router has a routing table, and every router has its own routing table, and so on. In 5G, it's like we can think about the software-defined network, where we can say, okay, we have an overview of the network. All the devices in the network can work as routers. Will have the same image that is somehow orchestrated by a main device that is the orchestrator and is telling how to route traffic so that everything gets better in the network. So it's not like you take a decision necessarily local, but you take a decision overall based on the congestion that you have on the network and other things. So going much more towards software, again, we have a problem because we can attack the software much easier. Okay. Now I will not move from the first generation to the 6 more because maybe it's not interesting. We will look into the second generation. The first is analog, we really don't care. The second has some nice, interesting security features that are the basis for 3G, 4G, 5G, and so on. 3G is somewhere in the middle between second generation and fourth generation, and it's something that it doesn't bring too much things. So we're not looking into that. 4G is kind of interesting, so we're going to look into that because it's bringing some improvements that are really important if we compare to the second generation. Now, just not to talk about like this, 2G, 3G, 4G, give me some names for them so that maybe it's clear for everybody. So for example, 2G, what is 2G?
Might be Tudor.
Might be. Sorry,
Tudor,
I didn't get.
as it starts with T. Do you want a name to?
Yeah, I want to, how do we know them? Or do you have some examples for 2G, for 3G, for 4G?
2G GSM.
Well, GSM, most of you probably heard. Yes.
Okay. 3G GPRS. And,
Okay, I would put GPRS maybe somewhere in the middle. But anything, anyway, here it's not something that this is really 2G, this is really 3G, it's like 4G now. 4G now is not really, 5G now. 5G now is not really 5G as it was supposed to be. But it's still considered 5G, okay? So many are somehow in the middle. Huh? Yeah. I would say UMTS here for 3G, and I would say LTE for 4G. And again, LTE should not be really 4G. It will be LTE plus it's the 4G. But we can say, okay, we can even put LTE simple here. So this is what we are going to study, GSM and LTE, just from security. They are more interesting, let's say, from a security perspective. Once we move along, we have increased security. We still have a lot of attacks. So don't think 5G is not prone to attacks. As I was saying, it is. And then we have increased experimentation, which might be good, which might be bad. And we will see that. And in what sense I'm referring to that? I'm referring in the sense that the attackers have now access to things that they did not have before. So before in second generation, let's say in GSM, you could have not put your tower and experiment with your tower to see if it's working or not working an attack. Now in 5G, you have simulators, you have emulators, you have there are small devices, software-defined radios, where you can define your own network. Okay, it's not legal if you're using bandwidth that is bought by network operators, of course, or you need to pay a license to use or so on. But you can work in a protected environment. You can work in a cage. You can work in a simulator. You can work. So there are many ways to increase experimentation with low cost. That before was not. Okay, so before only the network operators could have done things. For example, at the university level or researchers outside of the companies, you could have not said, okay, they can do something. Now they can, because of all these tools, which can be good or can be bad, because you can use them in a good way to check, okay, it's secure, it's not secure, I want to improve something, or you can use everything in a bad way, no, to mount attacks. Good. From our perspective, security, how it's normally a user in a mobile network gaining access in the network.
With provider, the network provider will rent or SIM, and they will use to say the SIM card to access the provider's network.
Perfect. So in the user device, it needs to be the SIM card, and we were talking even last time. Maybe the SIM card, as it is physically and we know it, can be replaced by an eSIM, okay, where we have all in software, smarter SIMs, yeah, and we were talking about that last time. But we need to have something, even if it's virtual software or physical, that it needs to be a SIM. This is how we're calling it, subscriber identity module, that gives access of the subscriber to the network. And if it's called SIM, subscriber identity module, what it needs to have?
An identity.
An identity, of course. That here I put an ID. It's an identity. So each subscriber needs to have its own identity. Of course, I need to know, is allowed to get in the network, yes or no? It's allowed to access roaming when it's traveling abroad, yes or no? It's allowed to access data, yes or no? How can I do that? I need to identify the subscriber in the network. Yes. If you want to add something, please.
Sorry.
No, if you want to add something, please just step in. And then, because we want security, we want authentication. No, okay, I have my identity, but I need to prove it's me. So I need to authenticate to the network, and then afterwards I want a secure communication and so on. I usually have also a cryptographic key in this SIM card, which in the physical cards, the ones that we're using up to now, even in 5G, nobody has a 5G phone, but I was saying, because we don't need it, as I said, we have even a key that is a master key, let's say, and we can, if we think about the Wi-Fi that we studied already, it's like the key in the Wi-Fi, the MSK in the Wi-Fi. It's something that I, as a subscriber, need to know. It's stored in the SIM card. It's stored in the tamper resistant in a tamper-proof location, let's say. What it means, tamper-proof?
Cannot be extracted. It cannot be extracted to say, but
yes.
No, sorry. Yeah, this is what I wanted to say.
Yes. So officially, I cannot read it from the SIM. Not even me. I cannot read it. And this is the key that all the security will be based on. And this identity and the key is also stored somewhere in the core network, in a database of subscribers. No? So here it's a database, and all the IDs with all the keys and so on are even stored there. And of course, everything, what I can do, what I cannot do in the network, I don't know, my history, my payment, and so on. Because we were talking about tamper-proof. So it means, okay, I cannot read it from the SIM. Again, it should not be like this, but it was possible, and there were simple devices some years and years ago. They were sold. I don't know if now they are even accessible anymore, or like some sticks, let's say, where you were putting the SIM card in. You were connected to the computer, and then with the software, you were just interrogating a lot of time until you were trying to find the key. And it was possible after some time to get the key if it was not burning the SIM card. So it is tamper-proof up to some point. But it's not easy to get it. And here are a lot of, again, as we move forward, there are a lot of protections that only the phone and can read it, and not at all levels in the phone, but just a specific one, and so on. So officially, we consider that this key is secured. So this is our assumption. We go with the key that is stored in the device, in the SIM card, and is stored in the core network, and it's considered to be secure. And it's also something that is happening, not to be leaked. This key should not be directly exposed. So I'm not using it directly, but what I'm going to do, I'm going to derive some other keys based on this key. So again, we have this key derivation. Again, we have the principle of the key separation. So I will derive keys for different purposes. Keys for encryption, keys for integrity where I need, keys for different connections, if I want for the data, if I want for the signaling messages, and so on. And this key should never leave the device and the core network. So mostly when I'm talking about mobile networks and I need to have mobility and I need to have even compatibility between networks, because I can go in roaming, right? I connect to another network. The key should not ever leave the core network and my device. So if I, for example, go in roaming, the visiting network should somehow talk to the home network, and I will explain the terms immediately, so that they agree in some way to decide who I am and what I'm allowed to do, without the home network giving my key to the visiting network. And now let's think about these terms, because I used two terms. First, I used roaming. What is roaming?
You are outside of your main network, like when you go outside the country?
Yes. So roaming means I'm not in my home network, and the home network means the network that my SIM card belongs to. So if I'm buying the card from Orange and I'm paying services to Orange, my home network is Orange. If I'm buying from Vodafone and Vodafone is the one that gave the card I'm paying to Vodafone, Vodafone is my home network. And then if I move abroad or even in the country, in an area where my home network doesn't have coverage and I cannot connect to it, then I am connected in roaming. To what? To a visiting network. So the network that is providing services for me on behalf of my home network, so they have all these agreements in between and so, because I cannot connect in roaming everywhere. Maybe you experience, no? You go abroad, you try to connect to some network, maybe if it doesn't work automatically, and it says you're not allowed to connect to this network, because that network doesn't have an agreement with your home network. Okay, so you cannot get access. You cannot authenticate in that network with your SIM card. So this is roaming. And then we also have the handover. Maybe it's less known as a term, handover. Do you know what handover is?
To transfer?
To transfer. Yes, the transfer from what to what? If I'm in a mobile network, what do you think?
From one network to another?
But that's the roaming, when I move from one network to another.
From one home network to another home network?
I cannot have two home networks. If Orange is my home network as I bought from Orange the SIM, it's Orange all the country. If I go to Orange in France, I'm still in roaming. It's another network. It's not mine.
I think sometimes you can move your number from one service to another, so from Orange to Vodafone or something like that.
Yes, I can do that. Yes, I can change the number, but that's not handover. And then I keep the number, okay, but the number is not the ID and the number is not K. So the number is something that is called MSIDN, Mobile Subscriber Identity Dial Number, I think, and it's a number, but that is not my subscriber ID. We will see what the subscriber ID is immediately.
When I'm transferring from one tower to another tower?
Yes, this is the handover. So I'm in the same network. It doesn't matter necessarily if I'm in the home network or in the visiting network, whatever. I'm moving in space. So I'm moving from one tower to another. That's the handover. For example, here, this is strangely, but this is how usually they are represented. No, we have a tower and the tower has a coverage area that is called, maybe you know, a cell. And then if I move in here, for example, I'm out of this coverage area. So I enter here, so I need to connect to this one. But while I move from here to here, so I leave this one and I connect to this one, I don't need to lose connectivity. And of course, from our point of view, I don't need to lose security. So somehow these towers, if I'm in 4G, they are smart enough to talk in between themselves. If I'm previous 1, 2, 3G, they are not so smart, they cannot talk, but they somehow go more for some, let's say, other devices that are controlling them. They do somehow so that I move from one to another without noticing. And keeping still a secure connection if it needs to be secured and so on. Good. Somebody said something about the identity and the number. No, before saying that, I was talking about the cells. Now, even if they are represented like this, don't think it's really like this. So when one cell ends, the other begin. This is not real. So normally we have overlapping. And you're all the time connecting to the one that gives you the best service, or it doesn't go under some specific parameter, so it makes you connect to another one. And we will see this because there are some attacks based on that. Because what can you do quite easily in an area? You can jam. What is jamming?
It's overriding a frequency so that you cannot connect to that cell anymore.
Perfect. Yeah. So if I want to jam, for example, something here, or this is going down because they work on different frequencies and so on, I still can have, if I'm somewhere at the border, no, I can connect to this or I can connect to this and so on. And usually there are also more layers. So I can have in the same area, geographical area, I have a coverage for 2G, I have a coverage for 3G, I have a coverage for 4G. No, so I don't have only one single generation, let's say. Good. Now, because we were talking about the identities. This identity, it's called different in different generations. This identity, it's called IMSI, let's say, Identifier Mobile Subscriber Identity, International Mobile Subscriber Identity. If I go up to 4G, it's called the SUPI, Subscriber universal, I think, something identity, I don't remember now. If I go in 5G, but it's the same thing. So it's basically an identity. Okay. The difference and why it's called different in 5G is because it doesn't only need in 5G to be the one from the mobile network. So it can be this IMSI that was from before, but it can be even a different type of identity for other types of devices. For example, if I have, I don't know, RFID devices or whatever. So things that are not directly using the mobile networks, but I still want to somehow connect them in the 5G. Before continuing, we take a break or we don't take the break? If nobody asks for a break, we go without break, like all the time. Okay. We go without the break. Now, how is this IMSI looking like? I will do a short parenthesis. Don't get worried that, I don't know, I'm talking a lot and you don't have access to all this information. I put here some courses from last year. So you will have this information even there, okay? How is this IMSI, let's say, looking like? It's very similar to a MAC address. And with some of you that presented the lab, the laboratory, the one with the Wireshark and the four-way handshake, for some of you I asked, or maybe for some of you I will ask, how did you realize which was the client and which was the access point in the laboratory with the four-way handshake, with the Wireshark capture? How were you realizing which is the access point and which is the client?
We can take a look to the first half of the MAC addresses, and the access point it's from one provider, and to say the client is from another provider. Yeah, from it's like Apple or Cisco or something like that. And this is one way to say to identify the each one each. And if we take a look only to say to the four-way protocol handshake, we can identify which one to say initiate the protocol, the airport protocol. So this will be the to say the authenticator, and the other one will be the client.
Very good. What I wanted to point out was the similarity between the MAC address and this identifier that we have in the mobile networks. Although they are also different, and I will explain now in a minute why. So in the MAC address, the first byte, the first part, it's giving us the manufacturer. And you were seeing there Cisco and something, Apple something, exactly as your colleague explained. So the first part of the MAC address was giving me the manufacturer, the type of device, and so on. The same is for the identity in a mobile network. So the first part of the identity in the mobile network, what can it give me?
The country code.
And?
The mobile, the network provider.
And a network provider. So the first part will tell me where is the SIM belonging to. So which is my home network? So if, for example, I want to search Romania, because we're in Romania, I see like this. All the SIM cards in Romania, the identity of the SIM card needs to start with 226, because 226 is the country code of Romania. It's not the 40 that is the prefix, okay, when I need to call for the phone, because I don't care about the number, the phone number. I care about the identity of the subscriber, so the identity which is stored in the SIM card. So whenever I see an identity starting with 226, it means it's from Romania. Then if I want to know even the operator or the next bits, let's say like this, are the operator. So if, for example, after 226 I have 10, I know it's orange. So the home network is orange. If after 226 I have 01, I know it's Vodafone. And then there are coming some other bits that are giving the exact ID of the subscriber. Okay? And that's why I was saying if I'm in Orange Romania or Orange France, I have different numbers here. Okay? So if I go to France, France will start with 208 in this identity. Okay? And if I want to go, for example, for Orange, then it will follow 29. So every SIM, Orange SIM card in France, it will start with 208 to 9. Okay, so basically this ID here is similar to the MAC address because the first part of it is giving me the home network, the country and the operator. And the others, of course, identifying the user itself. Why it's not similar to a MAC? Because the MAC is something that is belonging to the device, no? It's belonging to the network card, no? To the interface. So it's something that is hardware specific. Okay, if I'm not changing and how we were talking last in the last lectures, but normally it's something that it's not. If you compare the MAC and the IP, no, the MAC is something that is related to the hard, while the IP is something at a higher level. The same here, but this ID, where it is in the SIM card. So I can say, okay, it's something that is of the device if I consider the device being the SIM, but it's not of the phone itself. So it's not the ID of the phone. So if I take the SIM card out and I put it in another phone, I have the same ID, no, the same facilities, the same access in the network and so on. I have another ID that is belonging to the device itself or to the phone itself. And that it's called IMEI, International Mobile Equipment Identity. Okay, so that is, let's say, more similar to the MAC address in this way, because it's of the device. Now, if I have a phone that has 2 slots for the SIM card, it can happen, no? Maybe some of you have this one. Did you experience to be connected to 2 operators in the same time? The dual SIM, somebody has? Nobody? Okay. There are phones, you know, that are dual SIM or triple SIM even. You can put more SIMs, no? Then I will have more identities. Because for each of the SIM card that I insert, I will have an ID and the key. They each belong to a network. Each of the slots, there are like the network interface cards, they will have their own IMEI, so their own identifier of the card. Now, all these values you can find out easier or less easy. Let's say there are some codes that you can access so that it shows you the values. There are some apps you can download from the market, and then they give you some information about your connection, including your identities and the frequencies you're connected to and the operators and so on. Why are these IDs important from a security perspective? Where do we look at them as well, and not only to the key?
We can identify the person behind, say, the SIM.
How?
Initially, when you bought the SIM, that it's protocol to say, and I don't know if it's But anyway, so if you bought it from a shop, then they will identify somehow, and they will put the some notes in a database, and later on they can someone can identify if it's needed who bought or who have a certain SIM from a given operator.
Very good. I don't know if now for us, maybe somebody knows brought a prepaid lately. Do they ask your name when you get a prepaid? So not paying monthly fees, but just getting one card, as you say. You need to declare who you are or not.
You don't.
You don't. There are countries where you need to. So there are countries where even if you buy a prepaid, I didn't remember because I know at some point there was a discussion even here. If you get the prepaid, you need to declare who you are. Otherwise, if you don't go with an ID, they don't give it to you. So as your colleague was saying, they for sure know who you are, even if you get the prepaid. It's also a good part, a bad part, no? Because it's like anonymity. It's good to have it or bad to have it. It's good to have it because maybe I want to get it and I don't want people to know who I am and who I'm calling and so on. But then if I'm doing bad things, they cannot track me or it's more difficult. So they don't know who I am. So they want to know because if something happens from your phone or you do different things or I don't know what, they want to know who you are. So again, it depends. It's anonymity, privacy. But just to keep in mind, so there are countries where even if you take a prepay, you need to see who you are and go with the ID. And that's true. It's something that is connecting you to that phone. And it's connecting you with this ID, not the phone, with the SIM, no? And even if I take the SIM out and I use another phone, it doesn't matter because it's the same ID, okay? And then if, for example, somebody sniffs, and we will see that's possible to see, okay, in this area here, which are the IDs that are in the area? And I know this correspondence between the ID and the person, I can say the person was there, the person was not. So if, for example, it's I don't know, a protest or something, because now they're really on fashion, no? And I go there and I check, okay, give me all the list with all the IDs that are there in the square. Okay, I don't know, in the square at this moment, I can know you were there or you were not there, or in a stadium, okay? Even if on the stadium are thousands of people. So again, it might be something good, but it might be something bad as well, because it might be an attack against my privacy. This is with the ID of the subscriber. Then it's also with the ID of the phone. This email that I was saying, identity mobile equipment, international mobile equipment identity. So even all the phones have a number. So if you open your phone and you look at it, you will see there it's written email and the number. Again, this can be used in a good sense. And they can be used, of course, if implemented by the network operator against thieves. So for example, if somebody is stealing my phone and I know the email and I'm declaring it as being stolen, and the network operators are putting it in a blacklist, they will say this phone, this device, this identifier, this email, will never be allowed in the network because we know it is stolen. And then the person who stole it has nothing to do with it because it cannot use it anymore. And that's something that is device related. So it's not SIM card related. Okay. So like I have the access control list, you know, the ACL. What is an access control list?
It's a list that contains information about, well, let's say people that are permitted to access a network.
Perfect. Like this, I can have in a mobile network as well, based on the device, for example. And then I know it's a stolen device. It's not entering my network. It's not stolen. But again, it's something that the operator has to do, to keep this list, to update, and so on. So again, things that might go good, things that might go bad. Okay, so this is about identifiers in the networks. Of course, the network itself, it has an identifier as well, which is the identifier of the network. We kind of talked about it.
The number that you mentioned.
Yes, the number that I mentioned. So if we go back here and I go to Romania and I want to see, okay, which is the identifier of Telecom. Okay, they can be 2, they can be 3, they can be, depends on how many subscribers they have. Yeah. But for example, if I want Telecom Romania, it's 22606 or 22604. If I see this, I know, it's Telecom Romania. What is this happening? Or how is this working? All the towers are transmitting, like we had the beacons, no, in the Wi-Fi, saying, "Hey, I'm the access point here. This is what I can do. These are my capabilities. If you want to connect to me, you should know I'm here." No, these are these broadcast messages that are sent from time to time. The same is doing the mobile network. Okay, so the mobile network is sending via all the towers some messages from time to time saying, "Hey, I'm here, this is my frequency, and this is me if you want to connect to me." So it's sending these numbers, the mobile country code and the mobile network code. If the SIM card gets these messages, or the phone, no, it gets these messages and say, "Oh, this is my home network, I want to connect to it." It knows that the network is there, it's connecting to it. Okay? Any questions by now? Good. I have something else here, and then we will start discussing more in details the second generation. What is here? Something we kind of talked about before.
Can you repeat the question, please?
Yes, what is here in this side here?
Organizations that are responsible for certain, to say, developing the protocols, developing the standards, and so.
Yes. So again, one of the things you need to know is where to look for information when you need it. And this is something I'm really highlighting all the time, because it's like, okay, you take some courses, but at some point people need to be self-didact, no, or self-learning, how it's said. So you need to know where to search for the information. If we're thinking about mobile networks, we need to think about these ones. Some are the ones doing the standards, saying how it should work. Some are the ones that are not directly involved in the mobile, but somehow they can have some impact, or they have some good information. We already talked about that. So the 3GPP I showed you last time, right? How you can search for the standards in 5G. The ETSI, it's also doing standards for, it's the organization doing standards for Europe. It's called European Telecommunication Standards Institute. Okay. this is the International Telecommunication Unit. So these are all, let's say, organizations. 5G is what is, let's say, the logo of what is 5G nowadays. GSMA was another association that was mostly, it is still in networking, but was mostly in GSM second generation when it started. ENISA and NIST are based on security. So you remember we also talked about ENISA last time. No, the European Institute, no, for security, and the NIST is, let's say, kind of the same for US. The National Institute of Standard and Technology in the US, and all the standards that are adopted, let's say, in the algorithmic level. So whatever we learned by now, even in the Wi-Fi, no, they are standardized, let's say, by NIST, and they are also adopted and accepted in Europe as well. And of course, there's even IEEE that is important, and you can have a look and so on. But these are things that, again, when you need some information, you can just check there. They are not all. There are even others, but okay. Now I want to do two things. So I'll take the courses from last year's. And I will also take the exams from last year's, if you remember. This is the Romanian only. I want to download. Because some of these we already talked about, and some we did not. Okay. The second exercise we can do next time, because we will talk about GSM now. Okay. So from 2 years ago, I think was this one. Okay. So we can also talk about that next time if you want to have a look in and before. We already have one question here we can reply to.
Oh, 208 wasn't for Romania, it was for France.
Yes. Okay. So it's not correct. That was false, and it was asking to make it true. It was issued by a French mobile operator because we watch here and we see 208. 208 is France. Or if not, you can just change it, no, and put here 226. So you can also expect to have this kind of exercises, let's say, for the final exam. Now, just 2 seconds, if you can wait for me to get even the slides from last year. Okay, so if I put here online, okay, even some slides from last year's, they are both Romanian and English. I will not write them again for this year just to have. I mean, you can really use what was last year. It's not important the date or the name of the file here, and you will find more information here, and also from whatever we talked before and so on. And I want to kind of go over the GSM. Very fast because many things we already discussed. And to show you just how everything can be applied to GSM from what we talked and what is the main idea, let's say, in the GSM from security perspective. Okay, so as I was saying, we have the same architecture as we had in the general settings. So we have the access network, we have the core network, and we have the user device. The user device is split in two. At that point, we didn't have eSIMs or virtual SIMs or things like that. So we had the phone and we have the SIM, and it was called mobile station. In namings, you will see all the time it's a mess. They're changing, they're different, and so on. So it's called mobile station, made by mobile equipment and the SIM card. And then we have these antennas that here are called BTS, base transmission station. And they are not smart enough to talk directly. As we will see, it's possible in 4G, but they need, let's say, a controller, a base station controller, to kind of communicate with them and tell them what to do. And then we have the core network, and in the core network, we have these databases that I was saying that are keeping the subscribers' information. And here we have two important things like a difference, HLR and VLR. So it's the home location register and the visiting location register. What do you think is the difference between them?
Visitor is for roaming and home is, well, when you're not in roaming.
Yes. So basically we have two different distinct databases, because for the users that are mine, in the subscribers that are in my network, I can keep, for example, even the key, the cryptographic key we were talking about. The ones that are just visiting, I don't know that for them. I should know some keys, some things that allow me to get them access in the network, but I know much less information because the home network will send me only what I need to allow them access in the network and not more than that. What's usually happening in real life, it's everything is moved from HLR to VLR, including the ones that are the home subscribers, because it's easier to work with everything in the same place. And then after I do some steps, I don't really care about the key and so on, because I derived whatever I needed, and we will see that. Okay. That's important. Okay, that's the architecture. We don't need to know more. Here is the list that I was telling about. If we think about the IMEI, the identifier of the device, so when it's stolen, I can put it in a blacklist or something like that. What is important in the GSM principles? So what they wanted to do in GSM, okay, in security principles. Security requirements in GSM. So first, something that is really similar to what we saw in Wi-Fi. What was web coming from? Do you remember?
Wired equivalence privacy.
Yes, wired equivalent privacy. Why? Because we want it to be as good as the wired security. So we were aiming for the wired security. The same here. GSM was aiming for the security of the wired network. So it doesn't matter if I'm wireless, I want the same security. Okay, but like all the time, security mechanisms should not have a negative impact on the usability. And here we have a problem because we all the time have a trade-off between usability and security. efficiency, and security, and it will impact us a lot, and we will see that. Access control to the mobile station. Okay, so I need some authenticated user access. How I can do that? Nowadays on the phones, no, I need the code to open it, or I need a pattern or something to get access to the mobile station. Anonymity of subscribers. Keep the identity of the subscriber hidden to external parties. This is something they didn't manage up to 5G. Authentication of subscribers. So I cannot leave everybody enter the network like this and consume services, because I want to know who you are and what are you supposed to do and what are your rights. And confidentiality on the radio link only, and here we have a problem. This part here for sure is wireless. The other part here might be wireless or might be wired. Depends on how the network operator implements the network. We already know wireless is more prone to attacks. I can have jamming. We were talking about it before, so it's easy to do a denial of service. It's easy to capture the traffic. I just sniff it like I do for Wi-Fi networks. It's more difficult maybe to decode it, but it's possible. So if I just send like this voice, let's say over the air, it's not fine. Everybody can know what I'm talking in the phone, at the phone. What is GSM doing? Two things that for security are not perfect, let's say. One is thinking about confidentiality. So that means encryption. Okay, we encrypt. But what we encrypt? Only this part here until the first antenna. After the first antenna, you can do whatever with the data. The first antenna decrypts and sends it in clear in the network. And here it's not the home network still. And here we can still have wireless links. Okay, so that's a problem. The second one, we don't care about integrity. Like in web, we don't have any integrity protection. In Mac, what we had, the CRC, that was not integrity protected. Same here, protection, same here. We don't have any integrity. And the integrity here was assumed because integrity means, okay, we need to put something extra. For the voice, we have a problem because it needs to go really fast. Then why would I need integrity protection? Because anyway, I'm talking with somebody to the phone and I know. Because it's a friend, I know his voice, it's a family, I know his voice or her voice. I don't need integrity here. Okay, so these are two things that are not fine for GSM. What we already talked some vulnerabilities in GSM. One is breaking the Kerckhoff principle, and I think I've told you that before. A51, A52, these are algorithms for encryption. They were not made public at the beginning. A few months after they were available on the internet, they were broken. They were bad, cryptographically speaking, and the Kerckhoff principle was not taken into consideration. So never keep something private. Once it's found out, the algorithm, you might have a problem. Short keys, we will see. So it's very easy to do a brute force now. I already said limited encryption because we only encrypt up to the first link. Not mutual authentication. We don't have mutual authentication. Again, like we were not having mutual authentication even in web, no? In the personal settings, where the access point was not authenticating to the user, to the station, but the station was authenticating to the access point. The same here. The mobile station needs to be authenticated to enter the network, but nobody authenticates the tower. If somebody sets up a fake tower, I'm just connecting to it and giving whatever he's asking me. It's asking me tower, the ID, I give the ID. It's asking me, I don't know, a challenge on the key, I give the challenge, no, because it's going to be a challenge response mechanism and so on. No integrity, we already said. Active attacks are possible. So you can masquerade, you can set up a tower And users are not notified about the level of security used, even now. I don't know if you know, but there are some devices, very few, some phones, that are showing if you are using encrypted communication or not. And I'm not referring to something like end-to-end encryption on top of your communication. So if you, for example, use, I don't know, Signal and you know you have end-to-end security. No, I'm talking about I'm giving a phone call. I want to know, is my phone call encrypted? Yes or no? The devices are not showing this. And it's something that very, very few devices are showing. Then we have the mobile equipment. We said we have this email that is the ID of the device. There's another one less important with the software version as well. We have the SIM card. I was saying with this IMSI that it's the identifier, that it's important, and that in 5G it's called SUPI, but it's basically, it has the same role. There's another one, but it's less important for us. Let's say it's the ID of the physical card itself. It's not important. Then the PIN and the PUC, I suppose most of you know. No? Sometimes now we don't even use the PIN, the PUC, probably you haven't used in your life, but they exist. I think you know about them. Here is the list that we were talking at and how it's looking, the IMSI. Okay, so the mobile country code, the mobile network code, and then the identification of the subscriber, mobile subscriber identification number, which is something that is for each device, it's a unique number. Yeah, it's like the MAC address, I was saying, the manufacturer and then the ID. And then what in the SIM card, we have the identifier, we have the key, 128, quite low. And then we will have a challenge response mechanism. It needs to be temper resistant. We already talked about that. We also have some temporary identities that I was not talking about, but I will explain in a minute. What do you think is the role of a temporary identity? If we think about what we were talking about, anonymity and how this ID can impact my privacy or my anonymity by knowing who I am. What is the SIM? Yes, please.
An ID to use before knowing that you are connected to the right, I don't know, server.
How can I use it before?
Like use it first and then use the EMSI.
After I'm sure that I'm connected where I should be. That's a good idea, but I don't see how this can be put into practice, because if I give a temporary ID, I can do it in some scenarios and it's done in some scenarios after I've been at least once authenticated in the network. And the network also knows this temporary identifier. So you're right in this sense. So if I'm connecting to the network and I set up with this network some temporary identifier and we say, okay, from now on, I'm using this one. So you will know that this is me. When I connect next time, I'm sending this one. And you need to recognize me. If you don't recognize me, it means it's not you, the real network. But it can also be that the real network just loses my ID, like this happens. And then I need to somehow get back to the permanent one. And that's a vulnerability that we will find quite often in mobile networks. And in general, in identification and authentication. But you're right in the sense that it's something that I want to use so that I hide my identity. So I basically want to use this one instead of using the same ID all the time. So what I'm doing, I'm basically refreshing the ID from time to time. I'm getting these temporary IDs that me and the network, me as a subscriber and the network as my home network will know it corresponds to this permanent ID that was DMC. And I will use this one so that I change it quite often. And this has more benefits. For example, somebody cannot track me if I'm moving in space. If I'm moving in space and I'm using the same ID all the time, they can, if somebody is watching me, they can they can draw the map where I moved, let's say. Like Google is doing, if you put on Google Maps, this shows you, oh, you walked here and here and here. But if I change this ID temporary, and I change it in a way that the one that is tracking me or wants to track me cannot somehow match the one temporary ID to the other temporary ID, it will not know it's me. So it's more difficult to track me in time, geographically. So it's kind of a way to hide my identity, let's say. And this is something we will see even in 4G and even in 5G. So it's something that moves over, and it gives me this anonymity of subscribers. Not fully, but it tries to improve it. And then how it's taking place, the authentication. This is something that we need to know. Who can say what is this? Like type of mechanism.
It looks similar to the YAPOL and Radius protocol.
Kind of, yes, because I have the phone that looks like the station, right? I have the tower that looks like the access point, right? And I have the database with the credentials, with the IMSI and the key. By the way, here is KI is just how it's called in GSM because it's of the user I, let's say. That is in the database of the credentials, like in the radio servers, the authentication server. So it's very similar. Yes. And also similar to that, what I'm doing, I'm just sending the key like this. Or I have a specific type of mechanism that I all the time want to have when I have authentication. What do you think is this rand here?
It's like the initialization in IV or the non-C in the WPA protocol.
Kind of. I will go here in the web. Now, which was the web? Let me think. Maybe it was 17. No, this is WPA2. WPA, oh, so early did it. Does it look with something here? It can only be one thing. So, no, where was it? Here? What can be this random here? So I don't want something specific. I want the type of mechanism for authentication, let's say.
Pseudo-random number generator?
It's a random number, because this is why it's coming the random. Yeah, it's a random number. That is in fact what for my device?
A challenge?
A challenge. That the device using what? The key is going to compute an answer. So it's basically a challenge response mechanism like here. Hey, I want to authenticate. Oh, here's your challenge. That's your response. Okay, you're allowed or not to access the network. So, hey, this is me. This is my identifier. Okay, it moves forward. It's coming back a challenge, a random number. Using the key, I compute the response. This is the response. And here is checked, okay, is the response correct or not? If yes, you are allowed to enter and I send you the TMC, the temporary ID encrypted. If not, it fails the authentication. And now this random number and the response, how it's possible for the tower to check it? Based on whatever is taking from back from the home network. So whenever it's getting this request for, hey, let me in the network, I send it to the core network. The core network gives me a triplet, and the triplet is like this. This is the challenge. This is the response, the expected response. And here is a key that you're going to use for encryption. And what is happening? The tower is taking this first number, is sending it as a challenge. The device, the SIM cards in the device has the key, so it can compute the response. And now the tower has the expected response. It checks the expected response. It's the response. If yes, from now on, we're going to use this key. With which what it is, KC. It's the key used for confidentiality, so for encryption. So the encryption here is done using this key here. And this key here is derived from the master key, like it was even in web. So all the protocols in general have some building blocks, let's say, that are the same. And that's why when you learn kind of one or some basic things, let's say some stuff, then you will notice more and more similarities everywhere. Because there are the same mechanisms that are kind of reused. Okay, I use another key derivation function from KI to get the key. But it's the same idea because I start with the master key and then I derive the key that I want to use for encryption. Okay, here I'm using a different challenge response mechanism, but it's still a challenge response mechanism. I'm sending you something, you need to compute and send something back. Okay? And this is how they are called, the algorithms. They are also like modular. We can just use another one instead. These are not really algorithms. These are like, let's say, specifications of algorithm. Okay? For example, A8 says, this is how you should compute a key used for confidentiality purposes, so for encryption, starting from the master key and a challenge, a random challenge. Because I also don't want to use the same key over and over again for encryption, right? I want to change this key from time to time. So if I authenticate to the network more times, for example, I put down the phone, I restart, or I will generate a new key used for encryption because the challenge will be different. So I'll kind of refresh the key as well. Okay. And then how is this expected response computed? Again, it's based on the key, the master key and the random challenge, but using a different algorithm. Yeah. And this is what is called the triplet. I will go here because then you have just the explanation. This is what is called the triplet. And this is what the visiting network needs to have from the home network to allow visiting subscribers in the network as well. Okay. So that's basically how it works. And there's only one thing that it's putting everything in overview. Otherwise, it's just what we talked about. What is happening basically? So I have these three types of algorithm, let's say A3, A8, A5. A5, I use it for encryption because it's giving me the ciphertext from the plain text based on this key KC. So I encrypt communication up to the tower using this algorithm. What I see here, a big problem.
A small number of bits.
Yes, very small keys. Bad for brute force. Then how I derive this key? With another algorithm A8, which is taking this key and the random challenge. And then how I do authentication in the network with another algorithm that it gets the same challenge and the key, the master key, and it's computing the response. What I see here, another problem.
Also small bit.
Yes, 32 bits. 2 to the 32 is nothing nowadays. If the expected response is the same with the computed response, I authenticate in the network. If not, not. And this is if I want to look in the mobile station versus what happens in the core network, in the VLR. So basically what I have, even if I'm visiting, I have these triplets, which can be more for each subscriber. So this is the challenge, this is the expected response, this is the key that you need to use for encryption. They are coming from the home network. Okay? What happens in the mobile, in the device? I have the key. I use these two algorithms. One, I use it to derive the key KC. Based on what? On a random challenge that is coming from the network. Where is the network taking this challenge? From these triplets. That can be home network or visiting network that receives from the home network. No? What I do? I compute the response to the challenge, to the random, and I send it back to the network. And the network what is doing is checking for this random number that I send and this expected response. Is the expected response equal to what I got? If yes, you're allowed in the network. If not, not. If yes, then I can move forward and I use the key that was used for encryption to start using encrypted communication between the device and the network. And that's all. If you have questions from today's lecture, here they are just some small stuff. If you have questions from today. No. So then we close 2 minutes later. We see each other either Friday for the lab or next week for the course. Have a nice evening.
Oh, sorry,
Yes,
I have
please.
a question.
Please.
But about the what we need to do, o să întreb pe română, practica. Asta, ce faceți dumneavoastră cu, am văzut că aveți legat de CTF-uri.
Da.
Cum ne înscriem? Sau vă trimitem un mail? Ori care e ideea?
Da. Deci, cred că v-am și răspuns la mail.
Da, eu nu mai știu exact de unde am trimis mail-ul, că l-am tot căutat pe mai multe și n-am răspunsul că nu pot să găsesc nici.
Stați că vă zic, că v-am răspuns ieri, v-am răspuns. Pe sunibuc.ro Sebastian Liniuță Mihai .Mirleanu sunibuc.ro.
Da, m-am uitat pe Outlook, nu știu, poate Gmail, trebuie să-mi dau seama unde apare mail-ul respectiv.
Trimit pe altceva? Deci exact pe mail-ul ăsta cu care sunteți înregistrat aici.
Da, o să mă mai uit o dată atunci, mersi.
Pot să fac așa, îl copiez, dar aveți grijă pentru că altfel, deci exact de pe mail-ul de pe care l-am primit, am dat reply.
Ok.
Dacă nu-l găsiți, scrieți-mi, da?
Ok, da.
Ok. Back to English now. Other questions or we stop the course here?
Can you tell us about that as well?
The practica de CTF?
Yeah.
Okay. Also in English because it's English master, so I need to explain in English. Yes, I can tell you. The easiest thing to do maybe is to show here what I sent to him. So can I make public your email address that anyway everybody can see from the from the Teams? Okay. 2 seconds. Okay, so here I replied in Romanian. Okay, so what you need to do, basically you need to do like this: solve a set of problems, CTF. And if you have an account on Hack the Box, you just send it to me, the account, I add you to the university team. Then write a report with the problems that you solved, the exercises and the write-up, right? So the solutions. And we discuss it before sending further to the, because you will get an accepted, not accepted, maybe you also have to do a presentation. And then all the people that were involved in this practice with me, you only need to send me this report to agree on it. We can do it offline. We can have a meeting if you want. And then to have a presentation of what you did that is in common for everybody at a specific date. So we will decide for a date in the last 2 weeks. So in January, and you will explain, you will give a short presentation of what you did. Everything in English, of course, because we're in English. We also have a Discord, a channel. If you want, I can get you in. And now what is important, we have Unbreakable now. So Unbreakable, I've told about Unbreakable before. The easiest way to do your practice is go to Unbreakable, create an account, participate to the competition, participate to the talks. There are a lot of talks, webinars now that are interested. So we have here the calendar. And write everything in your report. You say, okay, I got an account for Unbreakable Romania this season. I participated to these 5 webinars. I did these problems because you have a platform where you can solve problems. And you put the solutions also so that you prove to me that you did them. You can also print screen the table because you will see there how many points you have, where are you in the ranking and so on. And then there is this individual contest starting on the 3rd of December. So you still have time by then, and you participate to the contest. And you tell me, okay, this is my nickname. You prove it's yours. So you give me some, you show to me when we talk that you can connect to account. And you give me some, I don't know, print screens in the report with your classification. It doesn't need to be high. So you don't need to be in the first ones, or there are people that never did this before. You will see it's not so easy when you start. But the thing about Unbreakable is that they're teaching you. So you start with very easy exercises. They give you hints. You get materials there. Once you log in, you will have access to materials that are showing you how to tackle with some problems, where to start from. And then if you want to, and I really encourage you to do, go and even participate for the team contest, where you can be more, even from the same master. And you just compute together for this other contest. And then based on all this, as I was saying, so everything finished now in 1 month. You write a report for me, you have a presentation, and that's your practice. It's kind of clear. No, you don't really need to, but I really strongly encourage you to do. Why? First, it's not only 1 day. So usually it's like the whole weekend. In the whole weekend, you can find 3 hours, 4 hours to try to do some problems. Second, you will see you kind of like it usually. So when you start to, what I'm saying, try at least, even if you don't want to go for the competition, to read the materials and do the problems, the CTFs, because they're the ones that are teaching you, and then it's going to be easier to solve problems. So in this report, you need, let's say, 10 problems to show me, okay? 10 exercises. And you will see it's much easier when you learn how to do some. afterwards. So I really strongly encourage you to do it. And then to participate, it's like it's nothing. It's in one weekend you can stay a few hours and try to solve some exercises. And you will see that the exercises are based on how difficult they are. So easy, medium, difficult, and so on. Larissa, I also saw you send to me. So I will maybe just forward you as well the reply that I sent to Sebastian. Yeah, I will even do that now, but I'm not saying anything, so I'm just copy paste. And so if somebody else is interested as well, just let me know and I can forward to you this. Okay, so I just copy paste and I send this to you as well.
I'm also
Okay.
interested in this, if I may.
You are Andrei?
Yes.
Andrei Tudor Gavrilo. Okay.
Yes.
So I can even forward this one to you as well. Okay.
Yes. Thank you very much.
Perfect.
Can you forward it to me too, please?
Okay. So we do like this.
And me, please, if you can.
Okay. Let's do like this. I put it here in the Teams. Okay. And then everybody can see, and then you see if you're. But it's Romanian, but it doesn't matter. Okay. I just put it here in Teams in the chat. Okay. And like, oh, that's not good because it's black on black. Okay, you just copy it and you put it somewhere else. It's black on black, but it's fine. Okay. The only thing, the Discord invitation is still up. So don't send it to other people because it's something for the university student only. Okay. So you can of course connect because it's something that it might be interested for you as well, but don't send to others. Okay, so it's looking bad, but you're security people, so you're just copying it and put it somewhere else. Okay, and let me know. So if you want to really continue with this, send me an email and tell me so that I know, because afterwards when we will have the meeting in January, I will do a doodle so that we have a date that is viable for everybody to have these presentations. Okay. There is one question from Andrei, or is just the hand that remained up?
It was just my hand that remained up. My bad.
Yeah. And again, the report, the presentation needs to be done in English, okay? Because the master is in English. The problems, they are not, okay? So you will have here in Unbreakable everything in Romanian. Okay, but you still use English because you will see most of the things will have some connection to English. If you need to do some attacks, or there is also a networking security part. So basically they are split into several domains, and there is also one domain that is network security. So you can also go for that. There's also crypto, there's also MISC, that is the masking between everything. There's reverse engineering. So you can go for whatever you like more when you solve problems. Okay, other questions? Anyway, if it's something unclear, just write to me. But take care to get the message back. If you don't get it, or you cannot access your email or something, let me know. You can even write on Teams if it's easier. Okay, so we don't really do hours. When we were at the university, we were doing some meetings. We have really, really good students that are computing in, even in the national team. They were going for I don't know if you know about this one, European Cybersecurity Challenge. That is basically the same, but it's for let's say international, okay? And it's also done with the participation of ENISA many times and so on. And we have some students, and now one in master, one even in undergraduate. No, 2 undergraduates that are in the national team for this competition. So then they've been like 2 years in the row or something. So they're really good. And they were also giving some hints about how to solve and how to do things. But now being online, it's difficult. And you have Unbreakable that is really, really good. So yeah. Okay, so if you have more questions, just let me know. You write me or you either on mail or in the chat in Teams. But again, let me know by the end of the let's say before the Unbreakable starts, okay? So that you can participate to the contest and everything. So you have like 2 weeks to decide. Okay, other things? No. Okay, so thanks for participating, and we hear each other again Friday or next week. Goodbye.